Hello guys, welcome to Energy Systems and Synoptic Link presentation guidance. Now, I thought I'd just send this screencast prior to the weekend so that if you were struggling on putting together your Energy Systems and Synoptic Link presentation, not quite sure what you had to do, this might give you a chance and I can kind of run through firstly why we're doing it, secondly how you would do it for one of the energy systems. Okay, so physiology focus, you're coming back and I really want you to have a real go at like kind of working on this physiology presentation. The focus of physiology is vital for the following reasons. Firstly, I mean, it's the biggest exam. It's 30% compared to 20% on the other two at the end of next year. But also, I think even more importantly, if you have a look at kind of the AS results that have just gone, 50% of students, so 1 in 2 students scored an A grade or scored A grades in the psychological and sociological themes, which is a second exam, whereas only 22% got A grades in physiology exam. And that to me, I just look at that and think, if we're getting kind of 35% of the students in our cohort getting A's, I think we can get more people up if we can just try and get this a little bit higher. Let's really try and get this physiology something that we're gonna understand. And that brings me on, I suppose, to these kind of the presentations. The key focus of it is so that you can demonstrate an understanding of how to explain and evaluate the 3 energy systems. But even more importantly than that is that if you can kind of the process of synoptically linking the energy systems to other areas of the physiology specification, you are starting to get to the position where you can actually retain information from the first year, but not only retain it separately, it's linking. And suddenly you're starting to think of things more synoptically, which means areas of the specification that link. And if I show you that now, what does that mean? Well, basically what I'm saying is when you look at physiology, you're basically looking at 2 things. You look at aerobic, which means oxygen is present, or you look at it anaerobic, where oxygen is not present when you move. So if I look at that now, we kind of look down to this one. If we have a look at how synoptically, how you link it across, you can have a look at this. So if you have a look here and start with the ATP PC system, straight away we can work out whether it's aerobic or not. No, it's anaerobic, because when you're using the ATP PC system, you do not require oxygen to break down the fuels of ATP and PC. Now, on top of that, if you have an ergogenic aid that could enhance the system, then it's going to be something that is that can be used without using oxygen. So you look down thinking, right, creatine. Creatine monohydrate is an example of an ergogenic aid that is anaerobically used or used by anaerobic athletes, for example, sprinters, shot putters. On top of that, you have anabolic steroids, exactly the same. Okay, people are using explosive activities. And if you flip over from that, okay, if you are using anaerobic or doing anaerobic activities such as shot put, discus, if you're using these type of kind of ergogenic aids, this would kind of make you'd have to utilize the muscle fibre, which gives you the fastest and most explosive force, and that is a fast twitch type 2B fibre, because that is the one with the highest speed and force of contraction. Now, if you go on from that, obviously, these are systems, if you're going to try and train to improve that, you're really going to be looking at 2 specific types of strength that would allow you to perform anaerobically, using PC, using creatine, and then also using these fibres. It'd be looking at these kind of maximum and explosive strength training. So that would be the way that you'd enhance this system. On top of that, if you do this, if you use this system regularly, anaerobically, which you'd have to, if you use, say, for example, creatine to enhance that system, not this, and then you go on to this and your fibres are being used constantly, the fast twitch type 2B fibres, or glycolytic if you want to call it that, and then on top of that, using these types of strength, you will create or you will gain adaptations to strength training, and that is, remember, our acronym, which is strength, which was used in last summer, was actually in your summer's AS paper. So that is just an example of what I mean by the synoptic link. All of this is anaerobic. All of these are used in anaerobic situations without oxygen, and that is why it's used for a shorter duration, but for the maximum force whilst taking part. So what I'm going to do then, if that's just me introducing you, what I was going to do for people who've got a little bit of apprehension about doing these presentations, I was just going to run through the ATP PC system and show you how you do the synoptic links at the end. So to start off, if you remember, we had this first one, you had to explain the role of ATP. So I've got these triggers here. It's ATP, currency, 3, how. So if that to me, I have to start off here. ATP, so adenosine triphosphate, basically consists of adenosine, one adenosine molecule and 3 phosphates. It is known as the energy currency of the body. It's the only usable energy source we can use. On top of that, it lasts for 3 seconds only in the first instance. Okay, and the way, how does this 3 seconds actually come to fruition? Well, it happens via ATP, which is located in the muscle sarcoplasm, is broken down by the enzyme ATPase. This will leave the product of ADP plus P plus energy. And that gives us our first 3 seconds of work. Now, the next thing I asked you to do in your presentations was, using the ATP PC system, explain an energetically coupled reaction. Okay, I'll put that twice just in case you missed it. So from there, what is a coupled reaction? A coupled reaction then is when the energy, because it's an energetically coupled reaction, from the first reaction is used in the second reaction. And what that basically means is, in the first reaction, it's an exothermic reaction. Okay, and an exothermic reaction is when a larger molecule is broken down to smaller elements. So what that means, and let me put that into terms for you. So reaction 1 is always an exothermic reaction because energy exits the reaction. So what happens here then is you have PC, which is located in the muscle sarcoplasm, is broken down by the enzyme creatine kinase. Creatine kinase will then leave the product, because it's broke down the phosphocreatine, it will then lead to a P plus C plus energy. The energy that is exited is via this exothermic reaction. So reaction 2 is an endothermic reaction, which uses energy to fuse together what was left. So if I explain that to you now. So there's reaction 2 in a coupled reaction. The second part of the couple, or the pair, is an endothermic reaction, and the E that was released up here is used to fuse the spare P that was released from the ATP breakdown to ADP to form ATP. So equation wise, E plus P plus ADP equals ATP, and that then gives us, I'll go over this in a second, that 10 seconds of energy. That's where we kind of use that kind of first, but once ATP is broken down, we have to look at a PC as a coupled reaction. So hopefully that makes sense and you can kind of remember that a bit. Remember, at the moment I haven't actually done the ATP PC system, I've just kind of used a coupled reaction within it. So it's important you know this concept of an energetically coupled reaction. That could be a standalone question. Right, let's get into the system then. So starting off, ATP PC system then. So the start molecule for this case would be ATP. ATP is broken down by the enzyme ATPase. This will lead to ADP plus P plus energy. Now this is an exothermic reaction because energy is released from the breakdown of ATP. Now if we get out to here, as a result of this first bit, ATP being broken down to ADP plus P plus energy, ADP levels rise. You don't have to put this, because that ADP level rises, it stimulates an enzyme called creatine kinase. Now creatine kinase breaks down phosphocreatine, which is located in the muscle sarcoplasm. The product of this is P plus C plus energy. Now on top of that, in terms of kind of how the equation to resynthesize it, is that kind of E that's released, the energy that's released from PC breakdown, is used to fuse the P back to ADP to form ATP, and then that is known as an endothermic reaction, which finishes it off and gives you 10 seconds. Now, at this point, you might just think, now, what kind of activities we talk about? 10 seconds of kind of energy that gives us. That 10 seconds of energy, what is happening? We're looking at a discus. We're looking at a shot put. We're looking at kind of a sprint start. Okay, these are the kind of things that you would look at. A rugby tackle. So if we go on then, evaluation of the system. So I've told you to use the fatty BCs in order to evaluate. So what you're looking here, I've kind of put some stuff here. So you have to answer these questions and put them into context. You might have done it your own way. So if I started off here and said, right, the key advantage of we've got to think the fuels. First of all, the fuel for the system is PC. Okay, now this is an advantage because PC is readily available in the muscle cell. However, the downside, to put the little red minus here, is that the PC runs out very quickly. Okay, so it's run out in 10 seconds. Okay, and then going down from there, is it aerobic or anaerobic? Well, it's an anaerobic energy system because it doesn't require oxygen to break down PC. Now, this is an advantage because it can be done quickly. On top of that, time. The downside to the ATP PC system is it only lasts for 10 seconds of time, which means it runs out relatively quickly. Another downside is the energy yield, because there is only one ATP, so that is a disadvantage there. On top of that, and another advantage, the byproducts, there are very limited, or virtually zero harmful byproducts of the ATP PC system, and another advantage is the complexity, because there is a relatively simple set of reactions for the ATP PC system. Now, site of reaction takes place in the muscle sarcoplasm, and then a sporting example of this could be shot put, discus, rugby tackle, and lots of different high jump. So you've got those examples there, long jump, any of those things that are high intensity, low duration. Now, that is my system finished now, and now what I need to start to get you to think about is, can we make some synoptic links? So can we start to link it? And I might run out of time, we'll see how we go. So going on then, first link that I'm going to use. So synoptic link 1, which ergogenic aid would enhance the ATP PC system? Well, we're going to look at nutritional one for now. So the nutritional one is going to be creatine. Now creatine is naturally stored in your muscle as phosphocreatine. However, the supplement or the ergogenic aid creatine is a synthetic form of creatine, usually in powder or tablet forms, and it's ingested orally to increase the PC stores in your muscle cell, so to enhance the PC. So it's not your real PC, it's artificial PC, which you're putting into your body, which will increase the amount of PC in there, in the muscle cell. Now, it's legal, okay? And on top of that, it is only really used, it is only used by anaerobic performers who need kind of real high strength speed formation. Now the advantages, the key advantages for creatine is it is going to increase your force and speed of contraction, and more importantly, it's going to increase 2 types of strength. It's going to increase the key types of strength here of maximal strength, okay, and explosive strength, because they are the 2 types of strength that are used mostly for like kind of anaerobically, certainly. So then we go on for another disadvantage. It can lead to sickness, it can lead to excess water retention, which would be 2 disadvantages there. So hopefully you see now PC, and the actual name of it is creatine monohydrate is a supplement. So that's phosphocreatine, the ergogenic aid is creatine. Let's go on then. So next one. So straight away now we're starting to think, right, so we're looking at the synoptic link to muscle fibres, okay, so now we're looking at kind of the muscle fibre use. So I look here and say, right, the types of muscle fibre that are used for the ATP PC system when using creatine are going to be the fast twitch type 2B fibres, the biggest fibres, the most explosive fibres, the fastest speed and the highest force of contraction. So what is within a muscle fibre such as the fast twitch type 2B fibre? Well, it has got high PC stores. Again, we've used the term PC in all 3 synoptic links so far. So it's got high amount of phosphocreatine located in this type of fibre. On top of that, it's got a high store of glycogen, okay, which can be broken down anaerobically, remember, as well. On top of that, the functional characteristics of a fast twitch type 2B is, remember, it's that FOC and SOC. So the key thing here is it gives you a high force of contraction. Okay, it gives you a high speed of contraction for the SOC, and hopefully you can see that now. Those fibres are so well suited to the ATP PC system, and for somebody who's supplementing their training with phosphocreatine. With creatine monohydrate as a supplement. So going on then, next thing. Now, when you are using the ATP PC system, if you want to improve your use of the ATP PC system, it's really important that you use weight training. And weight training is a really good method to improve maximal strength and explosive strength. Now, I'm very aware you could use for explosive strength plyometrics. I'm going to steer clear of that. So before we even start of it, weight training could be used to improve maximal strength and explosive strength. It should be done at least 3 times a week, and it should be done over a 12-week period to get adaptations. Now, let's get into the specifics, the parameters. So when training like this, what would I be looking at? Maximal strength there. The FITT process here is slightly different for strength training because we've got to look at it in this way. So if you're doing maximal strength, you'd be looking at 3 to 6 sets. You'd be looking at 1 to 5 reps. Okay, the percentage of your 1 rep max would be 85 to 95% of that 1 rep. It's the highest you can get. Then you'd be looking at work to rest ratio. You're looking at kind of 1 to 3 to 7. And then on top of that, you'd be looking at kind of a 5 minutes kind of recovery time between sets. Explosive strength then is we're looking at somewhere between 5 to 10 reps. Okay, somewhere in that range, and then we're looking at the percentage of the 1 rep, 3 to 6 sets as well. The percentage of the 1 rep max, we're looking at 75% to 85%, and then the work rest ratio, we're looking there at kind of 1 to 3 really. Okay, so 1 to 3 there, 1 to 2, 1 to 3, and then the minutes between, we're looking at about 4 to 5 minutes in that situation there to recover. So we get a full recovery of that PC, enabling us to contract explosively. Final synoptic link then, if you use the ATP PC system for a strength training, you will get these adaptations. So I've just put in green here the 4 I was going to use. So the first adaptation is to increase the synchronization and the recruitment of fast twitch type 2B motor units. For example, you switch on more of them more regularly and they coordinate with each other to give you a more forceful and explosive contraction. On top of that, you reduce the inhibition of the antagonist muscle, which leads to a more forceful contraction of the agonist muscle. And then finally, you have an increased hypertrophy